So let us refresh our mind regarding whatever we have discussed in the previous classes. Right now we are discussing the categorical propositions, and you have seen that the categorical propositions talk about the relationship between two categories or classes. For example, if you have all cows are animals as a categorical proposition, there you can notice two terms, cow and animal, and these two terms refer to two classes. The term cow refers to cow class, and the term animal refers to animal class. And the verb, the auxiliary verb are is called copula, something which is establishing the relationship of identity, in fact, between these two terms. So the first term cow is called the subject term. You are familiar now. And the term animal is called the predicate term in the proposition. So this way you have a structure in the proposition. The structure is precisely like this. In the beginning you have all or some. So that is called quantifier, something which indicates the quantity of the members of the subject class. And then you have subject term, and then copula, and then predicate term. So every categorical proposition has this very standard form, the standard organization, the standard structure, and we call them categorical propositions precisely because they talk about the relationship between two classes. Now, we have seen that if we talk about the relationship between two classes, then there are four possibilities. And while discussing those possibilities, we have seen that the first possibility is that either the subject class is completely included in the predicate class. That is, if all cows are animals, you consider this proposition, and this is factually true, then every member of the cow class is also the member of the animal class. And by using diagram, we have seen that either we can use this diagram, that is Euler's diagram, or we can use this diagram, which is Venn diagram. So here visually it is clear that the cow class is completely included in the animal class, right? And to represent the same thing in the Venn diagram, you can shade out the part which is exclusively the subject class. So you say that all cows are the members of the animal class. So they all are here. In this area, there is no cow outside of the area of animal class, right? So Venn diagram is suggesting that the area which is shaded out, which is gray area, is empty. There is no one. So all cows are animals can be represented in either this way or this way. We are going to use Venn diagram for our purpose because Euler's diagram has some limitation. So we will use only the Venn diagram when we come to the testing of the syllogism, etc. So this way we represent the proposition, and you know this proposition is called a proposition. All cows are animals. We call this proposition a proposition. This is a proposition. Now, when we talk of the exclusion of all the members of subject class from the members of predicate class, this is another kind of relationship. So for example, no cows are cats. That is, every member of the cow class is excluded from the members of the cat class. So no cows are cats can be represented either with the help of Euler diagram in this way, having two separate circles, or by using the Venn diagram, two overlaps, and we can shed out the common area. We can make the common area vacant, empty, and this way we can represent the proposition no cows or cats. So here you have this class as, let us say, cow class, and this class as a cat class. Let us say you can write some other symbol, maybe CA, just to differentiate between cow and cat. So, and you know that this proposition is given a name, E proposition. So no cows or cats can be represented in this way. Then in the above propositions we have seen the assertion regarding the whole subject class, all cows are animals or no cows are cats. So that is a complete assertion regarding the entire members, all the members of subject class. Now we can say that yes, only some members of the subject class are included in the predicate class. For example, some cows are black. So we can represent that very assertion, that very claim. Some cows are black means some members of the cow class are also the members of the class which is black. So how to say that? Either you can just write by drawing overlapping circle, you can write some cows are black, right? Some cows are black. So in the area which is common between the subject class and predicate class, let us say this is area of cow and this is the area of the class which is black. So some cows are black. That means in the common area there are cows which are black. So some cows are black can be represented in this way, or by using Venn diagram we can have just a cross in between the common area. So this is called I proposition. I proposition, some cows are black. So by putting a cross, what this cross represents that there are some members who are common between the subject class and predicate class. And this requirement, some member, this is minimum requirement. And you have seen that the minimum requirement is basically at least one, just one would do. So if you have just one cow which is black, you can very well say that some cows are black, right? So this requirement is a minimum requirement, at least one. That means it could be many, but certainly it cannot be all, right? So this way you can write. Cross means at least one member. It could be many, but certainly it cannot be all, right? So some cows are black can be represented in this way. Then the fourth possibility is that some members of the subject class are outside from the entire predicate class. From the whole of predicate class, some members are out. So here in this area, you have some members which are not members of predicate class. So consider if this is the cow class and this is the class of black. So we say that some cows are not black, right? So some cows are excluded from the entire class of the black objects or the black things, right? So this way you use Euler diagram to represent partial exclusion of the members of subject class from the members of the entire P class, right? And by using Venn diagram, you can use this cross, and cross means that there are some members present in this area. So some cows are not black. This is the area of black object, black things, and this area is not populated by some members of the subject class. So some cows are not black. There are some cows which are not black. We are not saying anything else, simply this much, that there are some cows or at least one cow which is not black, right? So by using Venn diagram, we can represent this proposition, and we have seen that this is called O proposition. Further, we have seen certain features of these propositions. So all subject is predicate, you call A proposition, and this is universal because it talks about all the members of subject class. Universal proposition. So it has universal quantity, right? The quantifiers in A and E proposition, these are two quantifiers, and these quantifiers say something which is pertaining to all the members of subject class. So these are called universal propositions. Similarly, some quantifier, some as quantifier, and that is why they are called particular all existential propositions. And we have also seen that A and I are affirmative propositions because they are talking about the inclusion of the members of the subject class into the predicate class. The proposition A talks about the inclusion of all the members of subject class into the members of predicate class, and the proposition I talks about the inclusion of only some members of the subject class into the members of predicate class. So these two are affirmative propositions because they talk about the inclusion of the members of the subject class into the members of the predicate class. Similarly, E and O propositions are called negative propositions because they talk about the exclusion of the members of subject class from the members of the predicate class. So no SSP, no cats are dogs, no cats are cows, right? You can cite such examples. So you are saying that no member of the subject class is member of predicate class, right? And they are completely excluded. The members of subject class are completely, entirely excluded from the members of predicate class. So that is the relationship of exclusion. Then some members of subject class is not the members of predicate class. So we call that proposition negative proposition, which talks about the exclusion of the members of the subject class. So if it talks about complete exclusion, then it is universal negative. And if it talks about partial exclusion, then it is particular negative. And these expressions are taken from the Latin words affirmo and nego. So A and I are affirmative propositions. They are borrowed from this affirmo. Affirmo means I affirm. Nego means I deny. So A and I are taken from the expression affirmo. They are affirmative propositions. E and O are taken from nego, that is negative proposition, right? So nego means I deny. So the propositions which are negative, they deny the inclusion. That means they talk about exclusion. Denying inclusion means talking about exclusion. And then the third feature which we have seen, that the term in the categorical propositions are said to be distributed. So the subject term and the predicate term. So in A proposition, we have seen that the subject term is distributed. In E proposition, we have seen that subject and predicate both are distributed. And in I proposition, no term is distributed. And in the O proposition, we have seen that the predicate term is distributed. And we have understood the meaning of distribution in this way, that a term in a proposition is called distributed if the claim of the proposition points out the entire class of that term. We talk about distribution. So distribution is not the property of the proposition, in fact. Consider, quality and quantity are the attributes or properties of propositions. But distribution is the property of the term, subject term or predicate term, right? So distribution is an attribute of the terms. whether term is distributed or not. And how we say that? A term is said to be distributed if the proposition, this is another formulation of the same idea. A term is said to be distributed if the proposition makes an assertion about every member of the class denoted by that term, right? So we say all S are P. That means all members of S are referred to. Similarly, when we say no S are P, so no member of S is part of P. So no member of S is part of the entire P, right? So this entirety of P is also referred to. So subject and predicate both are distributed in E proposition. I proposition does not make any claim regarding the entire or every member of the subject class. And O proposition says that some members of the subject class are excluded from the entire P class. So we are referring to all the members of P class, and by that reference we are excluding some members of the subject class from the entire P class. So the reference is made to the entire P class. That is why the predicate term is called distributed in O proposition. Now, suppose we are talking about subject and predicate term, and if we have the same class for subject term and the other class for the predicate term for all four propositions. So if all the four propositions have common classes as their subject term or subject class and predicate class, then we discover a relationship between them. We discover a relationship between all four propositions. So what is the relationship? That we will try to understand today. Now look at this particular square. A proposition is written here, E proposition is written here, I proposition is written here, O proposition is here. So look at this square. And this is just to have some kind of visual. And here proposition is also written. Every S is P, no S is P, or some S is P, some S is not P. Every you can make it our own expression, right? Instead of saying every, you can say all. Which in fact meaning is the same. When you say every member of subject is member of predicate, you are saying that all members of subject is included in predicate. So suppose we are now using subject and predicate common classes for all the propositions. What could be the relationship between all these four propositions? Now the relationship is called a relationship of opposition. Opposition is nothing but relationship. And don't take opposition in the literal sense. Here it is used in rather metaphorical sense, right? So we are talking about the relationship, and that relationship is termed opposition in logic. So you should not worry about why, what is opposition. Opposition is nothing but the relationship. So consider the relationship between A and E proposition. In logic, we say that the relationship between A and E proposition is contrary relationship. It is called contrary relationship. What is a contrary relationship? It is written here. Contrary relationship is that relationship in which the related propositions can be false together, but they cannot be true together. A and E can be false together, they cannot be true together. Consider, for example, if I say all cats are animals. So A proposition is true. And if you say no cats are animals, E proposition cannot be true, right? No cats are animals. Obviously, factually, it is incorrect, right? Suppose I say all cats are black. If I say all cats are black or all cows are black, you will say that this is false. And suppose I say no cows are black or no cats are black, you will say that is also false. So A and E can be false together, but they cannot be true together. That is the relationship called contrary relationship. A contrary relationship is that relationship in which the related propositions can be false together, but they cannot be true together. And you can cite examples like that, right? Now let us look at the relationship between I and O proposition. I is some S is P, O is some S is not P. Now suppose I say some politicians are honest. You will say this is correct because yes, there are politicians who are honest. And if I say some politicians are not honest, you will say yes, that is also correct because some politicians are really corrupt, so they are not honest, that is correct. So I and O, both propositions can be true with reference to the example which we have taken, right? And same thing you can consider in several ways. So the relationship between I and O proposition is called sub-contrary relationship. Sub-contrary. This is the relationship between I and O proposition. Sub-contrary. They are sub-contrary propositions. How do we understand them? How do we understand the sub-contrary relationship? We understand that two propositions, when they can be true together, but they cannot be false together. If two propositions are so related that they can be true together, but they cannot be false together, then the relationship between such propositions is called sub-contrary relationship. So you have just seen the example. I and O can be true together, but they cannot be false together, right? You cannot think of a proposition where I and O becomes false together and they cannot be true together. So the sub-contrary relationship suggests that the propositions which are in that relationship can be true together, but they cannot be false together. In the earlier case, in the contrary relationship, what have you seen? You have seen that these two propositions can be false together, but they cannot be true together, right? That is the contrary relationship. But sub-contrary relationship says that they can be true together, but they cannot be false together. So this is the understanding of sub-contrary relationship. So relationship between I and O is termed sub-contrary. Now let us see the relationship between A and I proposition. What could be the relationship between these two? Suppose I say all cats are animals. All cats are animals. And if I say some cats are animals, now it may look like little unusual because in the reality we say that yes, all cats are animals, that is true. But if all cats are animals, that is true. Some cats are animal is also true. We can accept that, right? And we are not claiming anything more. We are simply saying that some members of the subject class are also in the predicate class. If all the members of subject class are the members of predicate class, if that is true, then partial inclusion is part of the whole, right? So if A proposition is true, then I proposition is true. That is the situation which we call the situation of subalternation. Subalternation is the relationship between two propositions in which if the universal proposition is true, then the particular proposition of the same quality becomes true, right? A and I both are affirmative propositions. They have the same quality. So if A is true, then I is true. And this situation is called subalternation. And this is only one-way relationship. If A is true, only then we can say I is true. But suppose if I say I is true, you cannot say A is true. For example, if you say some politicians are honest, if that is true, you cannot say all politicians are honest is also true. So this relationship is one-way relationship. When A is true, I is also true, and this relationship is called subalternation, because we can decide the value of I on the basis of the value of A, not the vice versa. A is also called superaltern. This is superior, right? So this is superaltern. Superaltern. ALTERN. Superaltern. And I is called subaltern. This is subaltern. Okay? A is called superaltern and I is called subaltern. Why? Because if A is true, only then we can say I is true. We cannot say the other way around. If I is true, we cannot say A is true. Right? Same thing is here also. If E is true, you can very well say that O is true. There is no difficulty. If E is true, O is true, but not the other way around. Or if O is false, yeah, you cannot say anything about what is the value of E. Or if I is false, you cannot say anything. Then the relationship between A and O. If A is true, O becomes false. If O is true, A becomes false. This is biconditional relation. If A is true, then O is false. And if O is true, A is false. Similarly, if E is true, I is false. And if I is true, A is false. So when you have this situation between two propositions, when one becomes true, the other becomes false, which means they can neither be true together nor they can be false together, then they are in a relationship called contradictory. They are contradictory propositions if they are so related that if one becomes true, the other becomes false, and if the other becomes true, that one becomes false, right? So this is completely contradictory relationship. E contradicts I contradicts E. A contradicts O contradicts A, right? This way, we understand the relationship between all these four propositions, and these are the proposals coming from the Greek thinker Aristotle, and his followers proposed the square of opposition, and this is called traditional square of opposition. This is old one. Now there is a modern square of opposition, and that is developed by raising this question: what would be the truth value of the categorical proposition if the subject class is a null set or null class or empty class? Consider if I say all Martians are animals, the inhabitants of Mars, Mangal Grah ke sare prani animals. All creatures of Mars are animals, and there is no creature on the planet Mars. So what would be the value of the proposition if I say all Martians are animals, or no Martians are animals, or some Martians are animals, or some Martians are not animal? What would be the value of the categorical propositions which involved a subject class which is empty? There is no member in that. If there is no member in the subject class, whom are you going to include or exclude? Whom are you going to include in the predicate class? Whom are you going to exclude from the predicate class if there is no member in the subject class? So this question was raised almost 2000 years after the Aristotelian proposal. You know, the Greek philosopher, the Greek thinker Aristotle was in 4th century before the Common Era, and he considered logic which pertains to the kind of reality in which we live. So he was talking about the actual reality. He was arguing regarding the things which are available, which are surrounding us. And it is said that Aristotle did not consider any class, any linguistic entity which is empty. That is a kind of assertion made on behalf of Aristotle. By looking into his literature, we don't find any such explicit claims in the original literature, but the people who followed his logic, they started claiming that the Aristotelian logic does not consider the class which is empty or null, because they were realistic people and they considered only the actual classes. They were not into the fancy of all these empty and null sets. But look at George Boole, who was in 19th century Common Era. He raised this question that what would be the value of the proposition if there is no member in the subject class? And the answer which we receive from the followers of Aristotle and George Boole are strikingly opposite. So those who follow Aristotle, they say that we consider only actual classes. We don't consider the classes which are empty or null sets. We are arguing for the actual purpose. We are arguing for politics. We are arguing for establishing any claim in the jury. So we are not, in fact, dealing with any imaginary reality. We are dealing with actual reality, right? And therefore, there was no consideration of empty classes or null sets or the classes which are vacant, because the logical practices were connected directly to our life situations, right? You know that in Athens, political class was very powerful class, and the politicians were supposed to master, they were supposed to have skill of oratory so that they can easily convince the voters, they can easily convince the citizen, and thereby they can win their favor, right? So this way, the politicians used to argue, and if the politicians talk about the imaginary world, nobody will buy their ideas. So it is therefore said that Aristotle was not concerned about the classes which are empty, which are blank, and he was arguing about the situations which is actual. And therefore, there was no question of this kind that what will be the value of the proposition which is not involving any actual member, which is not about the actual reality. If you assume that yes, each and every class is the actual class, then certainly all four propositions have the kind of relationship we just talked about in the traditional square of opposition. But George Boole said that first two propositions, A and E propositions, do not have any such claim that there are members in their subject. And he said that A and E propositions do not have existential import, which means that the subject class of A and E propositions need not have any member in their class. Even then they will be meaningful. We can decide the truth value. So that was the difference between Aristotle or Aristotelian and Boolean. George Boole and Aristotle held different positions. So for Aristotle, all subject classes are actual classes, and therefore for him, universal propositions also have existential assertion, existential claim. But George Boole said that A and E propositions need not talk about the actual classes. They can be meaningful, their value can be decided even if there is no actual member in the subject class. So how it can be decided? He has proposed very nicely certain things. So let us discuss that. So consider, George Boole said that A and E propositions do not have existential import, means they need not claim that the subject class of the propositions have members in A and E proposition. But with respect to I and O propositions, he is in complete agreement with the Aristotelian interpretation. That means when we say that yes, some politicians are honest, so we are talking about, yes, actual members in the politician class, which are also the members of predicate class. But in saying that all Martians are animals or no Martians are cats, what are we saying? So let us see what George Boole proposed. He interprets the universal proposition in the form of a conditional statement. He says that the universal propositions are not existential propositions. They can be rewritten in such a way that there is no existential claim regarding that. So for example, suppose you say that all Martians are animals. So George Boole says that this proposition can be rewritten in the following way. क्या कह सकते हैं? If there is any Martian, then it is animal. If there is any Martian, then it is. This is the reformulation of George Boole regarding this universal quantifier. When you say all Martians are animals, what you are claiming here in this proposition, because Martian class is empty class, right? So how to ascertain, how to determine the value of this proposition? He says that yes, we can determine, and we can determine it quite meaningfully. How? We will reinterpret it. How it should be rewritten? It should be rewritten in this term. If there is any Martian, then it is animal. So suppose you see there are two simple propositions. There is any Martian or there is a Martian, then it is animal. So there is a Martian and it is an animal. If we talk in the conditional term, so there is no commitment. There is no commitment regarding whether the antecedent is true or the consequent is true. In the conditional statement, we are not saying like that. We are saying if the antecedent is true, then we can consider the value of consequent, and then we can talk about the value of that. So if say that all Martians are animals, if we rewrite that if there is any Martian, then it is an animal. So we are not committing to the fact that there is any creature called Martian. We are not committing anything. And if we look at the scientific evidence, so there we see that the antecedent, because there is no creature so far discovered which is Martian, so we can say that there is a Martian. This is a false proposition. We can say like that, right? The antecedent is a false proposition. And then what happens if the antecedent is false? Then we don't require even the value of the consequent. We can declare that this proposition is true, right? A conditional statement becomes true just by having this information that its antecedent is false. So we can say that this is true, right? Now consider this proposition, all Martians are animals. This becomes true, isn't it? And it is an animal. We don't require its value. We know for sure that there is nothing called Martian. कोई मार्स पे नहीं है, ये तो हमें पता है. तो बस इतना ही पता होने से इस पूरे प्रोपोजिशन का वैल्यू हमको निकल जाएगा. कैसे? जब हम रीराइट करेंगे इसको कंडीशनल फॉर्म में. अब आप इसको आप एक्चुअल प्रोपोजिशन में लगा लो. फॉर एग्जांपल, इफ यू से दैट all cats are animals and you say that this is true, rewrite it in Boolean terms. If it is a cat, then it is an animal. If it is a cat, then it is an animal. That is the understanding of all cats are animals. in Boolean terminology, right? And we can decide the value of that proposition. If it is a cat, consider any animal which is pointed out. So if you pick out any animal and you find that that animal is cat, so if that animal is cat, just by being cat, the animal becomes the creature becomes animal, right? So if it is a cat, then it is animal. So George Boole says that all cats are animal can be rewritten that if it is a cat, then it is animal, and this way we can decide the truth value of the proposition, right? But only when this question comes that the antecedent is false, then we don't require what is there in the consequent. So we can write conditional statement, reformulate the A proposition in these terms. Similarly, we can reformulate E proposition in these terms, and then we can decide the truth value. So considering this observation, now consider this particular proposition. A in this term. A proposition as rewritten here. So when you say all S is P, you need to rewrite if it is S, then it is P. This way you need to rewrite. All, this quantifier, all, universal quantifier can be rewritten in a conditional way if it is a yes, if it is S, then it is P. If it is Martian, then it is animal. So when you write all S is P, you just write a conditional statement. If it is S, then it is P. Similarly, you can rewrite the E proposition. No S is P. How you can rewrite? If it is S, then it is not P. आपको ऐसे लिखना है. If it is S, if no SP को क्या लिख देंगे? If it is S, then it is P. Then it is not P. Negation वाले को ऐसे लिखना है. Then it is not P. Okay, I hope you make sense of this. So no S is P can be rewritten in Boolean terms that if it is S, then it is not P. Similarly, you write here, if it is S, then it is P as the interpretation of A. Now you consider if it is S as false. So here also, if you have, if it is yes, then it is P. So if it is yes, that is common, right? In A and E proposition. That means antecedent is common in A and E proposition, and antecedent happens to be false because we consider that there is no member in the subject class. So if it is Martian, इसको आप थोड़ा सा रिफॉर्मुलेट कर सकते हैं. If it is Martian, then it is an animal, right? If it is a Martian, then it is an animal. So just by reformulating, it is a Martian. हम तो देखते हैं कि कुछ भी नहीं है. कोई क्रीचर है नहीं वहाँ. If it is a Martian, कोई क्रीचर है नहीं, तो ये फॉल्स हो गया. इट इज ए मार्शियन, ये फॉल्स हो गया. ये फॉल्स हो गया तो ए और ई दोनों एक साथ ट्रू हो गया. द मोमेंट एंटीसीडेंट बिकम्स फॉल्स, नो मैटर व्हाट इज द वैल्यू ऑफ consequent, the conditional becomes true. And with this effect, what is the problem? The problem is that we cannot hold contrary relationship between A and E. This relationship becomes invalid. We cannot. कैसे कहा था? Look at the traditional square of opposition. There we said that if the relationship between A and E we have called contrary, and contrary relationship says that these two propositions can be false together, but they cannot be true together. But when antecedent is false, in that condition, that means if there is no member in the subject class, in that situation, A and E both are becoming true. I hope you follow this. If there is no member in the subject class, then A and E both propositions are becoming true. And that is the violation of contrary relationship. So, by consideration of an empty class, the relationship between A and E proposition disappears. Contrary relationship disappears because in the empty class, in the null set, we find that A and E both are becoming true as per the Boolean understanding. Similarly, if you interpret this proposition, sum S is P, in Boolean terms, so you say that there is at least one thing, you say that there is at least one thing such that it is S and it is P. So you can write the, let me type, otherwise it will take time. If sum का मतलब there is at least one thing, there is at least one thing. Oh, कहाँ गया? कहाँ मैं लिख रहा हूँ इसको? There is at least ये ऊपर नीचे हो रहा है. Anyway, आप लिखिए अपने नोटबुक में the interpretation of I proposition. There is at least one thing such that if it is S, such that it is S and it is P. There is at least one thing such that it is S and it is P. This is the fact we were asserting in saying sum S is P. Some cows are black. So there is at least one cow such that that animal is a cow and that animal is black, right? There is at least one thing such that it is cow and it is black. This way we are saying some S is P, or some cows are black. Now, if we consider the empty class, the subject class as being empty, then what will happen? It is yes, this becomes false. So when you say conjunction, if it is reformulate कर रहा हूँ I proposition को, there is at least one thing such that it is S and it is P. So look at this, it is S and it is P. This is conjunction. So suppose you say some Martian is animal, and you reformulate that there is at least one thing such that it is Martian and it is animal. So it is Martian, that is false. यहाँ आपने देखा it is Martian, that is false. So और यहाँ ये conjunction है. So if one conjunct is false, it is Marcian, that is false, and then the whole conjunction becomes false, right? So then what is happening? I is turning false. So this is I proposition. And if you write O proposition, reformulate it, O proposition. So what you will write? The reformulation of O proposition, there is at least one thing such that it is yes and it is not P. That is the reformulation of O proposition. So if it is yes, if this is false, then what is going to happen? अगर ये false हो गया, if this is false, then what will happen? I becomes false because there is a conjunction here. Similarly, here this is becoming false, and because of conjunction, the entire O proposition is becoming false. So both are, I and O, both are becoming false. On what condition? If there is no member in the subject class. And what we have learned in subcontrary proposition, subcontrary relationship में क्या देखा था? They cannot be false together. They can be true together, but they cannot be false together. But look at this situation where there is no member in the subject class. They are becoming false. And therefore, the relationship between them, that is the subcontrary relationship, is gone. Similarly, you can test here. We said in the case of subalternation relationship, we said that if A is true, then I is true. If A is true, then I is true. But look at this situation. In this situation, A is true, but in the same situation, I is false, right? जब सब्जेक्ट क्लास में कोई मेंबर नहीं है तो A ट्रू है लेकिन I फॉल्स हो रहा है, यहां हमने देखा. इसी तरह यहां भी if E is true, O must be true. ये पहले देखा था सब ऑल्टरनेशन में. But now what is happening? If E is, here in this case E is true, considering that there is no member in the subject class, and O is becoming false. ये हमने देखा यहाँ दोनों false हो रहे हैं. So what happens? What is the outcome? Subaltern relationship is also gone. If you test the contradiction relationship, this will be present. सिर्फ एक रिलेशनशिप है जो बचता है और उसको आप देख सकते हैं. अगर A ट्रू है तो O फॉल्स है. इन द केस ऑफ A, इसी सिचुएशन में A ट्रू है और हम देख रहे हैं O फॉल्स है. अब आप O को ट्रू करने की कोशिश करके देख लीजिए. तो O को ट्रू करने का मतलब क्या है? आपको ये पार्ट ट्रू करना पड़ेगा और ये भी ट्रू करना पड़ेगा. और इसको ट्रू करने के लिए आपको P को क्या वैल्यू देना पड़ेगा? फॉल्स वैल्यू देना पड़ेगा. तभी नॉट P ट्रू होगा ना. इस पूरे को ट्रू करने के लिए नॉट P को फॉल्स वैल्यू देना होगा तो इट इज नॉट P ट्रू होगा. और जैसे आप P को फॉल्स वैल्यू देंगे तो यहाँ क्या हो जाएगा? P को फॉल्स वैल्यू दिया तो ये ट्रू इम्प्लाइज फॉल्स बन जाएगा. तो A जो है फॉल्स हो जाएगा जब आप O को ट्रू करने की कोशिश करोगे. सिमिलरली E will become false if you try to make I true. I को ट्रू करने का मतलब you have to make both of them true. ये दोनों को ट्रू करना पड़ेगा. But if you make both of them true, then what is going to happen? Here it is not P. ये यहाँ false है. This will become false because you have made P as true, right? So if antecedent is true, consequent is false, then E will become false, right? So when E is true, I is becoming false. If you want to make I true, then E is becoming false. And this way, the contradiction relationship holds. All other relationships disappear, right? And that is the outcome which we call the modern square of opposition. So I hope I have taken some more time. So you go through the textbook, जहां आपको पढ़ोगे और कुछ क्वेश्चन आएगा तो आप पूछोगे. So let me see if someone is alive. ठीक है, किसी को कुछ बात करना हो तो थोड़ी देर बात कर सकते हैं. आप लोगों ने सुना है कि मैं ऐसे ही बोलता रहा?